What is up? Welcome to our channel, Vadkakari, and I'm your presenter, Mike Wada. Okay, so if this is your first time to watch your videos and you want to actually, stay up to date, you want to receive much more of these videos, please make sure that you click on the subscription button just on YouTube that you are using to watch us from. Okay, and also make sure that you like this channel so that what that means is each and every single time we upload a new video, you'll be the first person to actually view our videos. Now, in this video, I want to share with you is about calculus. So this is kind of halfway to differential calculus that we studied previously, and I believe that some of you who followed me on the introductory part, you followed so well. So we did much more of the introduction, the emphasis, and on how you can just differentiate any given function or polynomial. And we saw the symbols that is used to represent the differentiation as a mathematical way of understanding that. So we looked at different, just basic examples that we looked at, but in this example, we are going to also, pick it up from where we left it from, okay? And also just advanced in the way that we will be able to answer such questions that you're able to see behind me. Now, fundamentally, you have to understand that calculus deals with, small changes, okay? Small changes in quantities, in different quantities, okay? And then also, if you did understand those fundamentals, then today in these examples that I have, we just want to do some of the more in-depth of how you can be able to do differentiate this given function with respect to maybe s with respect to t. Okay, it can be any of those letters from the alphabet. So differentiate with respect to x. We have the first one is saying 3x to the power 5 plus 7, x to the power 3 minus half x to the power 2 minus 1 over x. And then see it's saying open bracket 2x minus 3 close bracket power 2. And then we also have d, which is 4 over x to the power 3. Then the second equation is talking about saying find the coordinates of the points on the curve, and this is the actual curve, a function in form of an equation. So y equals to x to the power 3 minus 3x squared minus 9x plus 6, where the gradient is 0. Okay, so we are going to start with the first question, right? And then from there I'll be able to answer even the second question. Okay, so let us solve together. If this is your first time to our channel, please, we are asking you just to subscribe to our channel so that you receive more of these videos and other in different subjects. So kindly subscribe. If you're watching us from YouTube, if you're watching from Facebook, you can also follow our Facebook page, which is just Learn with Professor Wadia. You can just like and also follow us. Also on TikTok, where we also upload some of the short videos over the same, you can also follow me. That is just Professor Wadia on TikTok. You can go and search for me. Okay. So we're going to actually start with the first question, which is A. Now, what I want us to understand is, first of all, when you are differentiating, okay, when you are differentiating any function or polynomial, you have to understand that there are certain fundamentals or rules that we normally follow. Okay, just want to give you a quick one, okay. So if you are differentiating something which is like this, for example, this is just an example. Okay. So what you need to understand now is that every single power on each term of this function, okay, you have to ensure that, okay, you have to ensure that the power must be subtracted by 1, okay. So there's 1, subtract 1. And then the differential result of a constant number is always 0. So whenever you're differentiating a single number, a constant number, that number always gives you the result 0. Okay. Now, there is this symbol that you must be aware of, dy dx. Now, I want to put up a precaution, or rather a caution, to say, when you say dy dx, it is not a mathematical, just a mathematical, the symbolic mathematical of what it means to differentiate a specific function. So once we say dy dx, just a mathematical representation of what differentiation means. So this is not equal to some kind of a fraction, for example. It's not a fraction, okay? So make sure that it has no mathematical meaning, only to symbolically or mathematically give us a symbol of what is differentiation in terms of a symbol, okay? That's all we have to do and understand, okay? So, so what's going to happen is that dy dx equals to this. Now, this power multiplies with the coefficient of this term, okay? The coefficient. So this power multiplied with the coefficient of this term. So it's gonna actually more like be like x to the power 3 is going to be, this comes here, so 3x, and then the power reduces by 1, okay? So that is just how about differentiation, okay? So now in this case, what's going to happen is you're going to say 3x to the power 2. So this was a 3, so minus 1, then minus. So the power is 2, multiply the coefficient of this term, going to be 2x. Then this power reduces by 1, that's going to be just the power 1. So anything to the power 1 is just 1. It's just 13 plus, then there is you can see 2x. So by definition there is a power 1. Okay, so 1 times 2 is just that 2, and then this 1 minus 0 is 1 minus 1 is 0. So anything raised to the power 0 is 1. So this 1 times 2, you get 2, plus any constant, just 0. Okay? And basically, this is just the answer. Okay? So this is what you will be basically doing just in a second now. Okay? So I hope you have gotten the concept and also the fundamentals of what differentiation is all about. Okay, so now let's now get to the real examples now, so that we can see how we can apply the concept that I've just talked about. Okay. So now the first one is saying 3x to the power 5 plus 7. So 3x to the power 5 plus 7. Okay, so now before we start differentiating, you can just rewrite this one as y equals 3x to the power 5 plus 5. Okay, so that we have different variables within this function, so the y and the x. Okay, so we are differentiating this with respect to x, meaning x, y is the function of x. Okay, so it's going to be dy over dx, okay, equals to, so this power is going to multiply by this. So I'm going to say 3 multiplied by 5. You can do that, okay, and then the x and then this power 5 minus 1, okay, plus 0, okay, if you want to, okay. So dy, okay, dy over dx equals to 15x to the power 4, okay. That's the answer, okay. So that is the answer number 1. On number B, we are going to have 3x to the power that minus this x to the power 2 minus that. Okay. So now, one of the most important things that you have to understand is you have to ensure that anything, any term that is in form of a negative index or negative indices, you have to at least change them to the positive. Okay. So what's going to happen is that you're going to say y equals to x to the power 3 minus half x to the power 2 minus this. Okay. Now, once you do that, you say dy over dx. Okay. Now, before I do that, let me just change this one. So this is going to be, I'm going to write this. Now, this one, okay. This one, 1 over x, okay. 1 over x, 1 over x can be said as same as x to the power negative 1, okay. So x to the power negative 1. So make sure that each and every single time you come across with a fractional, rational, terms, like there is a combination of a variable and also a number. Make sure that you change them to the negative index, okay, or indices. So now this is going to be like 1 minus x to the power negative 1. So that we understand that the major thing we are doing, the reason why we are doing this is because we want to know what's the power of each term. Okay, what's the power of each term in this function? Okay, so that is one. So now we can now say dy over dx is going to be, this is going to multiply for whatever the coefficient is there, 3x to the power 2. And then this is just going to be minus x. So this part, okay. So this part, how is it coming to x? So half x multiplied by half. So this 2 multiplied by half. So half, okay, multiplied by 2. So this goes. So it just remains with x, okay. So this is going to become just x, and then this one is going to be this negative power multiplied by the coefficient. Now remember there is a negative there, so this is going to be plus, and then this is going to reduce by 1, okay? So this is just going to become that, it's going to become x to the power minus 2. So now once you do that, you can now say dy over dx, okay? dy dx, this is 3x to the power 2 minus x, okay? And then you can just regroup it, okay? So you can have you can just say 1 over x to the power 2, then minus x, okay? Or it's okay to just say dy, okay? Or you can have dy over dx equals to just 3x squared minus x, then plus 1 over x to the power 2. Okay, so you can also do whichever way you want. Okay, so that's our B. That's our B. Okay, we are going to look at now C. Okay. So when you look at C, we have 2x minus 3 to the power 2. Okay. So what you need to understand there is that you need to expand this. Okay. So this is going to be 2x minus this, then 2x minus this. Okay. Once you expand now, then you say this times that is 4x squared. Then this times that is going to be minus 6x, and then this times this is going to be minus 6x. Then this times that is going to be minus 9. Okay, so you needed to expand that. Once you expand that, then you can now say y equals to 4x squared minus 6x minus 6x. Of course, that's going to be this. That's going to be 12x plus 9. Okay, so now dy, okay, dy dx, this times that is going to be 8x minus 12. So this will give us 0. So 8x minus that. Okay. Okay, so now let's look at 4 over x to the power, x to the power 3. So what you can do is, can just be equal to y equals to 4 over x to the power 3. Okay, which is just 4x to the power negative 3. Okay, so make sure that we don't want to confuse yourself, because we just want to make this one a single term as to avoid the numerator and also the denominator. Okay, so this is gonna actually be dy over dx equals to, meaning 4 dot minus 3. Okay, so the dot means multiplication, and then x to the power negative 3 minus 1. So this is going to be negative 12, and then x, then to the power minus 4. Then therefore dy dx equals to just negative 12, okay, negative 12 over x to the power 4, okay. Okay, so ladies and gentlemen, welcome back. So in this second example, we are going to see how you can be able to find the coordinates of the curve, okay, whose gradient equals to 0. Okay, so previously we looked at how you can be able to just differentiate simple functions, polynomials, and things like that. But in this video, I'm going to show you how you can be able to calculate, or rather find the actual coordinates which actually intersect between the curve and also the gradient function. Okay. So now in this question, you're able to see that we have a question that says find the coordinates of the point on the curve y equals to x squared, x to the power 3 minus 3x squared minus 9x plus 6, where the gradient is 0. Okay, so the first thing that we're supposed to do is actually to understand what is it that you're looking for. So in essence, on this question, we are looking at finding the coordinates. Okay, so how do we find the coordinates? Okay, so the first step is that you have to differentiate. You've got to differentiate this equation. Okay, so y equals to x to the power 3 minus 3x squared minus 9x plus 6. So as we saw previously, that it's very difficult for you to actually differentiate something like this. Okay, So what I'm going to do now is just to say dy over dx equals to, so the powers, as we have already done that, so this is going to be 3x squared minus 3x, okay, minus 6x minus 9, okay. And then the differential of a constant is just 0, so we don't actually include that 0. So what's going to happen now is that after you do that, this is now what we call a gradient function, okay? So this is a gradient function, okay? So we are not actually finding the actual gradient, they have actually given us the gradient, which is 0, okay? So what we're going to do is we're going to actually equate this value to 0. So since they're saying that the gradient is 0, so we're going to say 3x squared minus 6x minus 9 equals to 0. So once you have something that is like that, which is so simple, what is going to happen now is that you can kind of simply reduce this by dividing a common number, which is just 3. So this goes out, okay? And then it remains x squared minus 2x minus 3 equals 0. Okay? So this is what we kind of menu. Now, from there, you can see that we have now a quadratic equation, okay? So we can use those methods of solving a quadratic equation that we know, like factorization. It can be used, even completing the square method or even the formula method. So you can use any of those two, okay? So now, let's now use factorization method. Okay, so now once we do that, what you're going to do is you can now find, say x squared minus 2x, okay, minus 3 equals to 0. So what's going to happen is that we're going to find the factors, meaning the coefficient of this x squared multiplied by this one is 1 times negative 3, which will give us negative 3. Okay. After you do that, now you look for any other two numbers which you can use in order for you to get a negative 3. So there isn't any other number that we can use apart from those two numbers. So these numbers becomes the factors, okay? And then the sum, okay? The sum is the number when you add the two factors, we're going to actually get minus 2. That is the sum. So if that is the case now, what's going to happen, or what you're going to do now, is now substitute these two factors into this part, or term, or 2x, or minus 2x. So we're going to plus. So x squared, this plus x, then minus 3x minus 3 equals 0. From there now we can group these to that. So when you factorize x outside, then x plus 1, then what is common between the two, we have negative 3, then x plus 1 equals 0. Okay. Now once you can now put together this x and the other x, x minus 3, then you pick one of these. So after reaching now at this point, you can equate each of these to 0, then x plus 1 equals to that. Now from there again, you say x equals to just 3, or x equals 1, negative 1, okay? Now once you do that, then these are just the values of x, okay, at which the curve is cutting the x-axis. So, but now we need the corresponding values of y, so that we can come up with the coordinate, okay? Because at the end of the day, what we need is x comma y, then x comma y, okay? That's what we are looking for. So now, okay, so what you're going to do now is to get the original equation, which is y equals to x to the power 3 minus 3x squared minus 9x plus 6, if I'm not mistaken. Okay, so that's the actual equation that we need. And then after that now, we can now, what is going to happen is that we are going to plug each of the x value into that curve or equation. Okay, so this is going to be y equals to, when x is 3, so this is going to be, okay, then, okay, now from there, say equals, this is 27, this is also minus 27, this is also minus 27 plus 6. From there now, you say this goes, then you remain with these two, then you can just flip them, 6 minus 27, which gives you negative 21. Okay. So now, that's the first, when x is 3, and then when x equals to negative 1, then you can also plug in. So when x is negative 1, then okay. When x is negative 1, then this is going to be negative 1, then this is 3, then this time that is plus 9, then plus 10. Okay, so negative 1 minus 3 is going to give us 4, negative 4. Then this plus that, it's 15. Then okay, so y equals to negative 4 plus 15. This is same as saying 15 minus 4. Then y equals to 11. Okay, so now therefore, now the coordinate now is that when x is negative 1, so we're going to say negative 1, comma 11, and 3, comma negative 21. Okay. So these are the two equations, the coordinates that we need for us to answer this question. So that's how you can simply go about answering this question. So thanks so much for watching our videos. Please, if you have not subscribed to the channel, make sure that you do subscribe, so that next time we do post something like this, you'll be actually notified that we, Radical Academy, we have posted something, so that you can check it out. So thanks so much. If you can also follow our Facebook page, which is as a lane with Professor Wada, and then also on YouTube, Radical Academy. So either of the platform, you can actually get all these content or videos that are that are going to help you actually understand more insight and get more fundamentals of whatever subject you need. So we provide subjects such as mathematics, physics, chemistry, as well as also biology, and also principles of account coming soon. So thanks so much, guys, for watching. I love you, and I'll see you in